Okay, so we are talking today about arithmetic sequences. You can also pronounce this word as arithmetic. Either way, you'll probably hear it more if you guys ever have this in another class, or if you have, if you look on the internet for different videos and stuff, you'll hear it as arithmetic, but it's the same thing. An arithmetic sequence, guys, is the same thing as a linear function. Linear function. What do we know about a linear function? It's a straight line. Good. What do I know about the slope? Does the slope change from one point to the next? No, it's constant. Your slope is always the same. All right. So you can think of these functions linearly. It's a sequence. It's not y equals mx plus b, but it's in the exact same form, okay? An arithmetic sequence has a common difference right here. Common difference. We're going to be finding the common difference. That's the same thing as thinking of slope, okay? A common difference in an arithmetic sequence is always adding or subtracting. You're always adding or subtracting. If it's multiplying, it's something else. It's called geometric, and that's our next lesson. If it's squaring, if it's, usually squaring is what you see. It's not arithmetic. Arithmetic just means you add or subtract the same thing every time. All right, does everybody understand that? The difference between consecutive terms, the difference between one term to the next, is you add or subtract the same thing every time. All right, so here we go. I'm going to go through just some examples. I know you guys can see this, but I want you to see. God bless you. If this is a sequence, right, they tell you that this is the rule. We'll use the word rule for a sequence. If you were going to find a specific term number, if I wanted to know what the 100th term was of this sequence, I would plug in 100 for n. You're going to be given sometimes a series of numbers, sometimes specific terms, and you're going to need two things in order to figure out what the rule is. Now, I'm going to show you two ways to look at it. You can do it either way. It doesn't matter, just as long as you algebraically show me. But to find the common difference, figure out what's going on from one term to the next. So in this case, how did I get from 7 to 11? I added 4, right? How did I get from 11 to 15? I added 4. How did I get from 15 to 19? I added 4. So in this case, you would say that the common difference, how I got from one number to the next, is positive 4. Do you guys agree with that? If we were looking at this linearly, your first term is 7, the second term is 11, the third term is 15. Your slope is 4. So if you notice here, if I was looking at this rule, your common difference, the number in front of n, is the same thing as your slope. Now what this is, this plus 3, is really your y-intercept. Because if this is my 0 term, right, your y-intercept is where x is 0. So if I'm adding 4 every time to go up, how would I get the one before it? Subtract 4. Well, 7 minus 4 is what number? 3, which is right there. So I'm going to show you a formula that you can use, or you can think of it linearly. Some of you are going to like doing that better, and that's perfectly fine. Notice here, guys, how this rule and this rule. Do you see how in one of them, 4n plus 3, the other one has 7 minus 5n? You can write it either way. Doesn't matter. I'm not sure how WebAssign's going to want it, so we'll look into that. But in this case, my common difference is negative because I'm going from 2 to negative 3. Then I went from negative 3 to negative 8. We're just going down, so that's why your common difference there is negative. Does everybody see that? Okay. All right, moving along. Let's go to some examples here. This is the formula on how to write an arithmetic rule, an arithmetic equation. A sub 1 is the first term, right? So if you have the first term, you can just plug it in there. The D, that is your common difference. That's like our slope. Remember, if you're talking about an arithmetic function, your common difference is going to be I'm adding the same number every time or I'm subtracting the same number every time. So you can use this formula in order to write your explicit rules the way that it sounds. So here's an example, right? We're going to do just a bunch of different examples given different pieces of information. So it says find the formula, write the rule. So that means I need a sub n equals first term plus n minus 1 times the common difference. What did they tell me here? They told me that the first term, a sub 1 equals 2, correct? And they told me that the common difference between one term to the next is positive 3. Everybody see that? So if we plug that into our formula, we're going to write our rule. The first term is 2 plus n minus 1 times 3. What do I do with that 3? I have to distribute it first. Good. So I have 2 plus 3n minus 3. Can I combine anything? Yep, positive 2 and negative 3. So my rule for this sequence of numbers, whatever it is 3n minus 1. So if I said to you guys, what is the 945th term? Where would I plug in the number 945? In for n. That's how you find the different terms. Questions? Pretty straightforward. All right, moving along. This is probably the hardest problem that we'll do in terms of arithmetic sequences. And it's not really that hard, just got to think just a little bit. But the question says to write the first several terms of the sequence. Okay, well, I don't know what the sequence is. Let's just figure out what they gave us. And I have to write the rule to find out different terms. So I know my rule. I need the first term and I need the common difference, right? Those are two things we need. So what did they tell us? They told us that the fourth term is 20, correct? And they told us that the 13th term is 65. You guys agree with me? All right, so how can I figure out what the first term is and how can I figure out what the common difference is? How many spaces, how many places are between the fourth term and the 13th term? 9. Okay, I agree with you guys. 9 spaces. All right, that's good. There's 9 quote-unquote spaces or numbers in between the fourth term and the 13th term. So when you're given a problem like this, where they give you 2 random terms in the sequence and you have to find the rule, you're going to set up a little equation to find what the common difference is. And the way that we do that, which term number is the furthest away from 0? The 13th term or the fourth term? I don't mean the number itself, 65 or 20, because it could be negative or positive, but which term number? The 13th term is further away, right? So I'm going to say, well, the 13th term is the same as saying the fourth term plus 9 spaces, right? You guys agree? 9 spaces of whatever that common difference is. I don't know what that common difference is. This will work every single time to do these problems. But you have to figure out what that difference is first. If it was 8 spaces away, you would take those 2 terms and you'd say, okay, I got to go 8 spaces. So let's fill in what we know. We know the 13th term is 65. We know the fourth term is what? 20 plus 9 times d. Now what? Okay, subtract 20. Good. So 65 minus 20 is 45 equals 9 times d. What's my common difference? Divide both sides by 9. And my common difference is 5. So from one space to the next, I go 5 places. Do I know yet what my first term is? No. So let's think about this. I know that my fourth term is 20, correct? In order to write my rule, I need to know my common difference, and I need to know what term? The first one. So if I know to get to the 5th term, I'd add 5, and this would give me 25. And then to the 6th term, I'd add 5, and it would give me what? 30. How would I go from the 4th term to the 3rd term? I'd subtract 5, and it would give me what? 15. But then how would I get to 2? Subtract 5 again, and I get 10. And then how would I get to 1? So what is my first term? 5. Do I now have enough information to write my rule? Yes. So we say, okay, a sub n equals the first term, which is 5, plus n minus 1 times the common difference, which, 5. What do I do with the 5 on the outside of the parenthesis? Distribute. So 5 plus 5n minus 5. What happens with the two 5s? They cancel, positive and negative. So my rule is a sub n equals 5n. They wanted the first few terms of the sequence. How would I find the first few terms? Plug in 1, 2, 3, 4, 5. Now you can check to make sure that your rule is right. What do you guys know the 13th term is? What did they tell us it was? 65. So if I plug in 13 right here, what's 5 times 13? 65, yeah. Here we go. You guys are doing fine. This is easy. Find the 54th term of the arithmetic sequence. Well, before I can say, okay, I'm going to plug in 54 for my n, I have to know what the rule is. So think about our equation. And again, I'm going to show you two ways you can do this. I always do it the linear way, which is the second way. But if I use the rule, a sub n equals the first term plus n minus 1 times your common difference. I need to know two things. I need to know what the first term is, and I need to know what the difference is. What is the first term of the sequence they gave us? 2. How did I get from 2 to 9, and then 9 to 16, then 16 to 23? What did I do each time? I added 7. So my common difference is 7. Agreed? So if we plug it in here, we have 2 times, plus n minus 1 times 7. So we're going to distribute our 7. So 2 plus 7n minus 7. What's my rule? 7n minus 5. Good. 7n minus 5. Now that didn't answer the question because we want the 54th term. So what do I do with 54? So if I'm going to find the 54th term, I say 7 times 54. That's the term number I'm looking for. Minus 5. What's 7 times 54? What's 7 times 54? 378. All right. So 378 minus 5 is? So the 54th term is 373. I need to see this part of where you got your rule to then how you got your answer. I personally would figure it out like this. Just me. All right. This is my first term, right? This is my second term. So every time we added 7, correct? So I know that that's my slope, my common difference, 7n. And then what is my 0 term? If I added 7 every time to go forward, how would I go backwards? I'd subtract 7, right? What's 2 minus 7? Negative 5. So there's my rule. I just do it that way. I don't like using this formula because honestly, I always forget that plus sign.
Are we going to have to do it?
You can do it either way. Now, when you do write your rule, it does need to say a sub n. Just like if you had y equals mx plus b, it wouldn't just be mx plus b. You'd have the y in front. You have to have, because we're doing our sequences in series. But either way is fine. All right, we okay? Okay, a couple more examples and then we're done. We're talking here about the sum of a finite arithmetic sequence. Guys, you will not be given any of these formulas. You need to know them. What does the word sum mean? Addition, thank you. Finite means there's a beginning and a what? And an end. Arithmetic means we're adding or subtracting, same thing every time. Agreed? Okay, so here's my formula. N is the number of terms that we're talking about. It's the number of numbers. A sub 1 is again your first term. And a sub n is the last term. Sometimes we know the last term, sometimes we don't. But we can figure it out. Very simple formula. Now, a question like this is ridiculously easy. I understand that. This is just for showing you purposes. If you want to know the sum of the finite arithmetic sequence, if I gave you a problem like this and all you did was add those numbers in your calculator and give me the answer, you would not get credit for it. I understand you could do that. You could do that to check. But we're going to use our formula. We're going to just use our formula so we can be a little basic here. And then we're going to get into some more difficult problems. Nothing you guys can't handle. Remember, I have 3 pieces of this. I have the number of terms we're talking about. I have the first term that I need, and I need the last term. So in this case, guys, what is the first term of this sequence? 1. It's the first one I see. What is the last term of this sequence? A 19. Okay, good. God bless you. How many numbers am I talking about? There's 10 of them. All right, we're going to talk about that. If you guys count incorrectly, then we have a problem. So if we just plug this into our formula, 10 over 2 times 1 plus 19, we can simplify this. 10 over 2 is 5. 1 plus 19 is 20. What is the sum of this finite series? 100. Sequence, I'm sorry. 100, right? And again, yes, I know you could have just gone 1 plus 3 plus 5 plus 7. Okay, I get that. But you're not going to get problems like that, so let's pay attention here. I have my last example, and then I have things that you might see on your web assignment that I just want to show you. All right, find the partial sum. Partial sum means I got to use this formula. There's 3 pieces of info that I need. I need the first, I need the last, and I need to know how many numbers I'm talking about in general, right? How many numbers am I talking about adding? How'd you get that? It says the 150th partial sum. They want you to add. There's 150 numbers you're adding together. Do you know the first term?
Yes.
What is it? 5. Do we know in this sequence what the 150th term is? No. So again, we can do this one of 2 ways. We can use this rule to write a rule first. We can use this formula, I'll say. And I could say my first term you told me was 5 plus n minus 1. How did I get from 5 to 16? Adding 11. How did I get 16 to 27? 11. 27 to 38. Add 11. Just make sure it's constant. So my difference right here would be 11. So when I distribute, I get 5 plus 11n minus 11. What can I do with 5 and negative 11? What is it? 11n. What's 5 and negative 11? Guys, positive 5 and a negative 11 is not 16. It's minus 6, okay? So my rule here would be a sub n equals 11n minus 6. What am I looking for? The 150th term. So I have to say 11 times 150 minus 6. What's 11 times 150? 1,650. All right, minus 6. So the 150 term is 1644. Okay. You could have also done the other way if you wanted to. You could say a sub n equals, well, my common difference or my slope is 11n. If I add 11 every time to get to the next one, how would I get to the one before it? We would subtract, right? What's 5 minus 11? Gives me negative 6. That's, again, how you could write your rule doing it that way, too. Totally fine. So now, do I have enough information to find this sum? Yes. I take my 150 numbers, divide by 2. I take the first term, which was 5. Add it to the 150th, which is 1644. So 150 divided by 2 is 75 times, what's 1644 plus 5? 1649. Multiply those two together, please. 675? Yeah. Okay, perfect. Now, if you didn't know how to arrive at that answer, and you were really going to try and get this problem right, you would have to, how many terms do we have here? 1, 2, 3, 4, 5, 6. You would have to add 11, 144 more times, right? And then add all those numbers together. So a problem like, what's the sum of the numbers 1 to 20? Probably not going to get. A problem like this where you'd have to use the formula? Absolutely. Does that make sense? All right, 2 questions you might see on your web assignment. I want to bring these to your attention just so you guys don't email me and say, I didn't know how to do it. Okay, we talked about a problem like this. This is summation notation, correct? What is this question saying? Not the question itself, just this right here. What is this saying? They want me to start plugging in what? 1, and end with 250. Once I plug in 1, 2, 3, 4, 5, all the way up to 250, what do I do with all of those answers? I add them up, okay? Again, that would take forever, right? So this is the same exact question of the first one we did, where they gave us the numbers and I could see what I'm doing. If I'm going to find the sum, this is the formula that I have to use. First term, last term. In this case, my last term is the 250th term, right? How many numbers total do they want me to use? 250. That's my upper limit. What is the first term and what is the 250th term? How would I figure that out with this information? How could I figure out what the first term in this sequence is? Plug in 1. To find the first term, I'm going to plug in 1. What's 970 minus 1? 969. That's the first term of this sequence. How would I find the last term? Plug in what? So 970 minus 250 gives me what?
720.
720. Okay, good. So now do I have all the information I need? Yeah. I can find the sum of this. I say 250 divided by 2. And then I say the first term, 969. 969 minus the last term, 720. Calculator, what's 250 divided by 2? Okay, 125. And then what's 969 minus 720? Hang on one second. What's 969 minus 720? I'm sorry, yes, plus sign, my bad. I don't know why I said that. Thank you. 969 plus 720. Thank you. 1689. You guys agree? Okay, I'm just going with what you're saying. Now, multiply those two together. 211,125, which is the answer that's right here, correct? That's why I left it there. So again, that is the exact same question as here, guys. You didn't have to find the rule. They gave it to you. It's just in a different notation. It just looks a little different, but it's the same thing. Same exact thing. Say they said that n, your lower limit was 5 and your upper limit was 250. How many terms would you be talking about? 245. Because they want you to start with the 5th term. Good. All right, look at this last one. I want to show you this because every single one of you will have a question like this on WebAssign. There's a couple that are a little tricky. That's why I'm going to let you work on it tomorrow in class. If you have questions, you can ask me. But I need the sum of the integers from negative 40 to positive 50. So I want the sum of the integers. Sum means I got to use this formula. From negative 40 to positive 50. So think about it. Negative 40 to 50, right? I already know two things right off the bat. What is the first term they want me to use? Negative 40, good. What's the last term? Positive 50. Now, here's where I want you guys to see this. And I answer this how you would. How many numbers, how many terms, how many integers are from negative 40 to positive 50? 90. Okay, 90. All right, let's work this out. So I have 90 divided by 2. My first term is negative 40, right? Plus 50. So 90 divided by 2 is 45. Negative 40 and 50 is 10. So my sum of these integers is 450, yeah? But what does WebAssign say the answer is? 455. Guys, how many integers are there from 0 to 9? 9. Nope.
10.
From 0 to 9, how many are there? There's 10. All right, when you are including, you guys always have to account for one extra. The way that you think about, remember this, right? Write this down. You subtract integers of interest, we'll say. Integers of interest. I-N-T-E-R-E-S-T. Integers of interest just means, what are my two integers of interest that they're talking about? Negative 40 and positive 50, right? So you subtract integers of interest, then subtract 1. You have to, when you are including the number on one end and the number on the other, you have to subtract the integers of interest, then subtract 1. So if I say 50 minus, well, no, I'll do it the way it's written. Negative 40 minus 50 is what? Negative 90, so then minus one more, negative 91. So how many integers am I really talking about here? There's 91. So if I do my formula, 91 divided by 2, again, negative 40 is my first one, 50 is the last one. I have 91 over 2. You guys with me? Okay. Times 10. What does that equal? It's 91 divided by 2 times 10.
45.5 times 455.
What's 91 times 5? 455. Which is the correct answer. So on these problems, and some of them are tricky, I understand that. We did that on purpose because you're going to have problems like that on your test. You have to account for all of the integers, including the ones, the bookends, the one on the end. So you always are going to subtract the integers of interest, then minus 1. You guys got it? All right, so tomorrow, I would start your web assign tonight. We have 10 minutes. You guys can start now. I would start your web assign, and then you guys can come in tomorrow with any questions, like, hey, can you help me with this? I'll let you guys work together. I would not suggest coming in tomorrow and trying to get it all done by the end of the class period. That is not going to be beneficial for you.